Hello everyone, welcome back to RBBB Labs.
This episode we'll be running the electrolytic cell to make pure silver. We've even lashed out and done some time lapse for you on this one, so I'm pretty excited about that.
Alright, let's get into it.
We now have, I think this is about 3 kilo, a bit over 3 kilo of silver shot.
Lovely.
It's you can see some gold through there and some tarnish.
Bit of plastic.
So that's probably, what would you guess, about 98% pure, because it started out 92.5 as sterling, and we've got a lot of the copper out. But what we're going to do now is put it through our electrolytic cell and refine it to at least 4 nines pure, I'm guessing.
We'll do some close-ups of this.
Alright, what we also have is our
Silver nitrate.
silver nitrate. That's the electrolyte for the silver cell. Now, I made this from our silver from the previous batches. You can see how clear that is. So if there's any copper left in it, it would have gone blue. If there's nickel, it would have gone green. Gold would have gone yellow. But it's beautiful and clear.
So it shows our finished product is nice and pure.
Very pure. I've melted or dissolved silver from other things like even American buffaloes and Canadian mint and some Australian mint. And that is just as clean, if not cleaner, than anything else I've ever dissolved.
And how much did you dissolve into this beaker?
That's about 13 ounces.
13 ounces.
In what, a bit over half a litre? So she's concentrated, but we'll dilute that a lot.
And I can tell there's a lot of silver in there because this weighs a lot more than what half a litre of water would. It's got some weight to it.
Should check that, that's interesting, isn't it? But yeah, she's got some density. All right, so I think now we actually are going to set off this silver cell. And what I'll do, I'll try and time lapse it so that we get a beautiful view of that lovely crystal growth.
Yep.
This is one of the prettiest parts of the whole process.
Yep. The finished crystal is just beautiful, which you'll see shortly.
All right, so this is the first stage of setting up the electrolytic cell. So this is dacron, the Americans call it. So it's I think it's a half a micron mesh, double thicked over, but I just buy these as there's some sort of fruit storage bags, or I think they use them to extract milk from nuts and like that, things like that. So,
we can beat that.
What we have here, this is our first stage, and this is our basket that holds the impure silver in the electrolytic solution so that the electrolyte can start attacking it and refining it. So this is everything we've got here we've made, and it all works perfectly well. So it's just a little plastic container drilled with holes, and I put this dacron in it to make the filter basket.
So that just helps capture any impurities that are left after dissolving into electrolyte?
Yeah, and we process this when we finish just to get anything else that's valuable out of it. But what it will leave behind is any plastics, and you get a black sludge, a horrible black sludge that stains your hands like you wouldn't believe. But it would have all sorts of things in it, like plastics, and we'd even have gold, a small amount of gold, which is what we try and recover from it. But God knows, what else would it be?
Now, how much are we going to process through this silver cell with this run?
I think I tend to get, my memory's failing me, 1.6, 1.7 kilos of pure silver crystal each run.
And that'll take roughly a week?
A week. Conditions are a little bit colder at the moment, so that might slow the process down a little bit. But yeah, I think a week's fairly realistic.
We're up on the northern tablelands, and if anyone's been watching the news, we just had 40 centimetres of snow, which we haven't seen for
Well,
since '86, basically.
No. They say that's unprecedented, I believe.
For the amount, yeah.
All right.
So have a look at that shot. So as you can see, there's a bit of tarnish on there, and that's why we run it through the silver cell to just make sure we get out all those impurities.
What do you think the gold is? It's copper, but
we've had gold impurity before, and that was through cross-contamination, usually of using the wrong crucible when melting. We've made that mistake a couple times, but we try and label them now to make sure that doesn't happen again. Because as far as impurities go, having gold as an impurity in your silver is, well, it's just wasted gold.
It's not. It's not good.
It's not
just
good.
It's just an impurity.
An expensive impurity, though.
All right. Other than the messy technique, which someone will have to clean up later on, there is our basket with our charge.
Now, how often will you recharge that basket?
It eats it away fairly quickly. Probably about once a day. I come and check it for that week, and put in a couple of spoonfuls every day. So, all right. Are we ready to set this off, Blake?
Yeah. Well, should we get the electrolyte in there?
All right. This is our homemade silver cell. So, our power source, regular power supply. Our homemade anode, which is copper wire, and I've poured pure silver around that, so that's our pure silver anode, and our recently altered basket so that we can film it and see it. Usually you would have had, look at this for progress. This was the previous lid, sat on top of there, little inspection thing for, sometimes I have to top up water, and just giving it a stir and making sure that the crystal doesn't grow up and make contact with the basket, because if it does, it effectively shorts out and will just burn holes in that dacron, and then the black sludge that I was talking about will really quickly rain down. That can't happen. We can't let that happen. If we do, you've got to basically start it again. So we've gone from that lid to this lovely clear Perspex lid.
Which will mean when we put the time lapse on, we'll be able to see it grow very nicely.
Hopefully.
Hopefully.
Yeah,
Fingers crossed.
I accidentally lose the footage or something. Right, silver nitrate. Now, I'm going to put in about most of this, but I want to save a small portion of it because this electrolyte can be used twice. But I just save a portion of it to refresh the second run, and then it gets saturated. You'll see this will change colour to a very dark blue, greeny sort of colour as it puts the other metals into the solution and rains out the silver onto the silver bowl, which is our cathode. So yeah, we'll save a little bit of that so we can refresh the electrolyte before we run it a second time. So that's probably, I dare say, I put about 8 ounces of silver in there.
Now the basket needs to sit in that material to complete the cell.
No, I'm going to give it another mouthful because either. Yeah, that'd be 8 ounces.
Our distilled water. That's our distilled water machine.
You know what I say to that? Too slow. They go too slow.
Some people say haste makes waste, but not us. Yeah, that's much better.
Yeah, I prefer that. If it could be done with a power tool, do it that way.
Yeah.
Right. That water is quite cold. I dare say that was... Maybe I should have heated that, you know.
Well, it's going to be time lapse, so it might take an extra day or two, but for purposes of the video, it'll be super quick.
I would guess that water was probably only a few degrees. All right, so we put the negative. So this is just a bowl from, you know, your kitchen supply place with a strap around it and a little metal bracket I made just to get the to make the whole bowl the negative. Why did I make that so long?
How much power are we going to run through this cell?
Watch this. It's a constant 3.6 volts is what I'm chasing. So, you know, what's that equivalent to? A couple of little AA batteries or something. So it doesn't require a lot of power, but what it requires is constant power. So once we put it on, we will see the interplay between the amps and the wattage. They go up and down depending on how well the system or how fast the system is running. So we've got that in there, in with our basket. There's a bit of a void in there, but that will work. So that drops down and puts that into the solution.
Is that enough solution? Yeah. No.
Not enough water.
That's okay, we'll top that up. That way that makes sure the circuit is complete.
Saturated the bottom of that, and that solution is now all around the base of that metal.
And you can see how concentrated, even with all that water that we've added.
Yeah, they don't like to mix very readily, do they?
No, you can see the wavy lines in there. I think the camera picks it up, showing how much silver nitrate's in there, how much silver is dissolved in there.
Let's give it a stir. A little more uniform. All right.
One last thing to do.
Ready? Ready? Ready?
We're ready.
Let's set this off.
Okay, we've got some different numbers on the dial now. But we're still holding at about 3.6 volts, so that's good.
She's off.
And now crystals are growing.
So probably in about 3 hours we'll see the crystals start to form on the bottom, and then they'll slowly spread out until we get it full of these beautiful things here, and they are so pure. And it's, yeah, very, very nice to work with too once it's at that stage.
Pure silver crystal. Melts so nice. Pours even nicer.
All right.
All right, we'll get the GoPro set up for time lapse.
And then we need to start working on the press and everything to get some rounds, some queens made.
Yep, make some blanks, and then I don't think we've used our new dye for the silver bullion, have we?
No.
So first,
we've got a few new toys to play with.
Yes, looking forward to it.
From here, oh, you got it. From here, I can see the this is a work of art. The silver cell. From here, I can see the anode and the camera, but from the top here, I can see the power supply and the
numbers.
The GoPro screen.
There's one slight problem with this setup. It's definitely built for someone as tall as you.
No, right.
Oh no, tippy toes.
Okay,
It works.
I'll accept that criticism. I thought you were going to say you needed it changed, and I thought, oh no, they haven't put handles on it.
We'll give this a nice coat of paint later as well.
Well. I'll just disconnect this. So,
have a look. Oh,
strangely, this, well, not strangely, I suppose, because of the temperature, this actually took about 13 days, where it usually takes about 8 days. Crystal looks a little bit different as a result. Maybe not as chunky, but it's all pure silver. So if we can do this without making too much mess, not the ideal way.
there's still plenty of silver in that.
Yeah, heaps of silver. That electrolyte can be used again.
And we've got enough shot to run it at least one more time.
Yeah. So that's it. She needs washing to make sure we get all of that electrolyte off.
It's beautiful. Yeah, when we did this in summer, we definitely had bigger crystal growth, but they are still fantastic. Now, what high-tech tool are you using to...
I believe this is my WorkSafe building site license.
Seems appropriate.
I want to give up building, you see, and just play with silver and gold. So first step is destroy your license. Right. Now this rinse water will have a small amount of silver in it, so we'll save it and recover it. But it's largely water now. A bit of boiling water would probably be the go. Let's boil a little bit of water and wash it with that.
I think we're running low on beakers.
So you can still see that's got some blue there, so if we don't wash that away, that's an impurity that will come over. But look at
That's a pretty good crystal.
they're really quite small compared to usual, but it's all still pure silver.
Yeah, I just got a close-up of our silver bits from the last silver cell.
Yeah, they were nice, but that went so fast. I was thinking I might even have to cool it down during summer.
Not a problem for winter.
No. No, it doesn't seem so. All right, so while I dry this, we're going to do a silver shock pour. I'll recover that. So we will also set up to melt some significant amounts of silver.
Yeah, nice hot water.
Yeah, it's pretty clean already, but 2 more washes and she'll be done. We lose, you can see that small amount of floating silver that we lose, but it's negligible and we will recover it.
We will not waste a gram of silver.
It's pretty clean. Whoop.
Alright, transfer to a Pyrex baking dish on the heat. Beautiful.
Wow. Water bottle's always empty.
Looks like silver coral. Then once that's dry, into the furnace, melt it down, pour it into shot. Pure silver shot.
And we can find out how much we made.
Yeah, and then melt it down again into thin bars, roll them out, make some blanks, press some coins. Okay, let that do its thing.
Maintenance required.
Get the tools.
Look at that. So that's the wash from the electrolytic cell, not the electrolyte itself, just the wash. And there's that much silver in there to recover and go again. So nothing gets wasted, like we keep chasing that last little bit.
It looks so nice. It's like pure, well not quite pure silver, but silver stalactites. No, stalagmites. No, stalactites.
All right, we're getting there.
Join us next episode where we fire up the furnace again and melt down that 999 silver crystal.
Once that's done, we've got our pure gold, we've got our pure silver, and we're ready to start making some coins.
Thanks for watching. Please like and subscribe. If you have any comments or questions, leave them down below.
Thanks again.